All right, we have started. Welcome, everybody. As always, I'm Justin Meyer, and with me is Alexis Abril. We're going to get started with going through last week's answer for the make utility layer, and then we're going to get started in talking about how this works. Again, if anybody has questions or comments, you can find us and good place to ask questions at Bitovi/JS training. Sorry, this is at GitterIM Bitovi JS training. And also every week on Bitovi's blog, so if you go to bitovi.com, blog, after every training, we're putting up a training series article with all the information from the previous training. And here you can find the video, the slides, and any exercises, and a link to next week's exercise. So if you're already finished last week's, then maybe just go to this site, and I also posted this in Gitter, and grab this, because this is what we'll work on at the end of the lecture. And this is the one I'm going to work on right now, completing. So let's go through this real quick. You can see here, this is making it, but not the way that we want to make, because we want to be able to support divs and forms and all different types of elements. So I'm going to restructure this a little bit to use an array, and I'm going to put my tag names in there. I'll put all the different tag types I might want to create, such as h1, anchor, div, form. I'll put in a label, and you guys get the idea. Now what I want to do is, and in previous lectures, we talked about how JavaScript, you can kind of code your code, right? You can programmatically build the structures that someone else would use to, build whatever they're trying to build. This is a very common technique used by a lot of open source libraries, jQuery in particular. What this means is I can make my make utility programmatically. So I'm going to do that by looping through all the tag names. There's a bunch of different ways of doing this. I'm going to use the kind of, lowest common denominator. Wait, yep, I can make my font size a little bit bigger. Thank you for that comment. I don't know, how do I hide? Is there a way to hide this on the top? There we go. Okay, hopefully that's a little bit easier to read. I'll go one more. There we go, 150%. So I'm going to do it kind of like the lowest common denominator way, using a for loop. I is equal to 0, I is less than tag names length, I plus plus, I plus plus, and
JSPin just died for you.
What?
JSPin just died for you.
Yeah, JSPin just died for me. I'm gonna turn auto run off. If this ever happens to you with JSPin, I might have to. Here's some other debugging tools. Well, if you ever encounter this, you can go to the task manager of Chrome. You could see which task is running at 100% or very high CPU, and then end that process. And then I'm going to restart it, and hopefully it didn't actually save my changes, although I feel like it might have. Might have to create a new one. Oh no, it didn't save anything. Okay. So I'm going to turn this auto run off so it doesn't do that. I'm going to program it out. So here we go. I'm going to make my tag names again. I'm going to make a few this time. And then I'm going to loop through. And for every tag name, now you might be thinking I can do something like this. For every tag name, I want to get each individual tag name. And then for every one, you might be thinking I could just do something like this, tag name equals function. I'm setting a property on make called tag name, so it'll be form, then h1, then a, then label. And inside here, you might think I can just do something like this. I just create the document element using tag name. So what do you expect the problem here is, Alexis?
It's something on face value I would expect to work, but this looks very similar to that same issue we had in the last week's slides when we were talking about how things are passed by reference or passed by value.
Yeah, exactly. The problem is that even though I'm trying to create links and anchors, I should only be I'm only actually creating label elements. If I inspect these elements, you can see they're labels. And that's because tag name, when this for loop exits, is always left at the last tag. So the way to fix this, or one of the ways to fix this, is instead having a self-calling function. Here I'm going to have a function, and I'm going to call it right away with my tag name. That's it, each individual tag name, and I'm going to write tag name in here. Now I've created a scope kind of local to this function that when tag name is looked up, it's going to find each individual tag name. So can't read the JSBen URL. Okay, so I guess I can share this then. With people if they want to watch while I'm making these changes. Alexis, you want to share that? It's
yeah, QAGR.
Yeah, GIRA1. Okay, so now when I run this, I get hello world can.js. Now there's one other way that is a little bit easier if you're using modern browsers which support for each function on arrays. And you can see here, this is actually going to make this for each function on an array calls back another function with each item in the array. So in this case, it's going to be called back with the tag name. And you can see here's like a local kind of private scope that contains tag name. I could actually just do this in there, and everything should work. So that's another way of doing it, probably the way I would do it if I were doing it today. Okay, so now let's get into our exercise, our lecture for today. We are talking all about what this is. So again, welcome to Bitovi's JavaScript training, where the goal is to learn how to make any big complex JavaScript application by the end of the year. I'm your trainer, Justin Meyer. With me is Alexis Abril, and we're going to talk about what this is and go through exercises where we actually build the dot operator in JavaScript today. If you have any questions, go to that Bitovi JS training Gitter room and ask us questions there. And please ask questions because it helps us answer things. So again, let's talk about last week, what we learned last week. We learned about how closures work, and closures work with this combination of when functions are defined and when functions are called. So whenever you create or define a function is created in memory with a prototype property that points to an object and a hidden reference that that points to where the closure in which the function was defined. So this function happens to be defined in the kind of global scope in the window, so it knows that it was defined in the window. And then again, this is a bug. I must not have saved my slides from last week, because this should be called FN. And then whenever you call a function or invoke a function, those mean the same things, a new call object is created, and it contains all of the arguments passed into the function, and it contains what this is for the function, and it will contain any variables created inside the function. So that's what we learned last week. This week, we're going to learn what this is, and this is one of the most confusing and sometimes difficult things to talk about, because when you say this, like, what is this? Oh, this is this and this is that. It's hard to talk about as a trainer. So normally when I'm doing it in person, I'll put quotes whenever I'm talking about JavaScript's this. I could talk about it as the contextual this, to distinguish between the indefinite pronoun this and JavaScript's contextual this. So this week's training is brought to you by Bitovi, the company that's doing these trainings. We do front-end consulting, design and development, and trainings. So if you're looking for people to help your company or team build something awesome, we can help you with that. So how does this work? Let's first start by looking at a few simple examples. Here I've created a dog object with a bark count property that points to a function. And inside the bark function, it writes this bark count plus. So Alexis, if I were to run this code, what would this be?
I feel like this should be dog.
You are right. Dog in this case, or sorry, this inside this function is going to be dog. Now, let's say I did something a little bit different or strange. Let's say I created a bark variable and pointed it at what dog.bark points at. So bark is now pointing at the same function in memory that dog.bark points to. And then I were to call the bark function. What is this going to be?
I feel like since we're creating a reference to that function, this should still be dog at face value.
Yes, you would think that, but you would be wrong. It's one of the confusing things about JavaScript when you come from other languages, that this really has no bearing with how the function is defined. It has everything to do with how the function is called. So what does that mean? Well, in this case, this is going to be the window object. We'll talk about why. There's a few other ways that that functions can be called and that control how this works. So another one is I create another function in memory. And again, whenever you see a capital function, that isn't actually any different than a normal function. It's just by convention, people use capital letters with functions that are intended to be called with the new operator. So when you, I guess, how do I rephrase this in a way that might make more sense? Essentially, functions are just functions in JavaScript, whether their variable is capitalized or not. This is just capitalizing it is just a convention that means, hey, you should call this function with new. But anyways, when you use the new operator to call a function, this is going to be a new object that essentially inherits values from person's prototype. So P, what this new person returns, which is P, is what's going to be also this inside this person function. However, just to kind of hit the point home again, if I were not to call person with the new operator, this, in this case, is going to be the window. The reason is because whenever you call a function, without new, without dot, this is always going to be the window. Now, there's two other ways that you can call a function that are pretty similar that allow you to programmatically specify what you want this to be when a function is called. They are a call function and an apply function that are on other functions. So here I have dog.bark again, and now I'm creating a cat with a weirdly, for some reason this cat has a bark count property. What I can do is I can say call the dog bark function, but so that this, when this function is run, is going to be the cat, and I want to pass it a single argument, as barks is 1. So in summary, real quick summary of all of this, and I'm going to go into a few examples. What this is inside of a function doesn't matter how the function is defined, right? Where you see that function, if it's in an object or it's defined as like a variable, who cares? It does not matter. All that matters is how the function is invoked or called. And there's these kind of 4 main ways of calling a function. There's just the normal call operator when you have essentially parentheses after a variable, and that will just call the function, but this will be the window. The next is the dot call operator, where you have a dot, you have some kind of variable followed by some properties on the variable, separated by the dot operator, kind of code that looks just like this, and then you call parentheses after that. That's the dot, as in this dot, call operator. What this does is calls the bark function so that this is always going to be puppy. Basically, whatever the value left of the rightmost dot. So if you had foo.puppy.bark, well, it's still going to be puppy is still going to be this. And then there's the new operator, where this is going to be an instance of an object that inherits from dog's prototype. We'll talk all about what that means in a little bit. And then finally, a call or apply, which you can programmatically specify what you want this to be. So real quick, I want to go through another example that I think is often helpful. So people always get, this is one of these common problems that people have understanding how this works, especially when you pass a function to something else. So let's say I created that same dog setup before, where I had my dog object, I had a bark count, and I had a 0, and I had a bark function. I'm incrementing bark count. Now, a lot of times, or maybe I'm console logging, I'm incrementing it and console logging it, so I would see a bark. Actually, you know what I should do this in? I should do this in JSBin. So let me get rid of some stuff in this JSBin. So here, if I run, I just want to make sure it's working. Okay, so here, I can console log dog.bark. But let's say I wanted my dog to bark every in a second, or every 2 seconds or something like that. I could do a set interval. And you might think, hey, why can't I just write dog.bark to get called in 200 milliseconds? Now, if you do that, you'll see I'll get not a number every 200, or every 2,000. Every 2 seconds, I'll get not a number. And the reason is because when you pass dog.bark, you're just passing a function, and set interval is just calling that function back. The dog dot part of this is totally lost. So let's change the example real quick so it just does this once. Let's do set timeout. Clear, and I will run. And after 2 seconds of running, I get not a number. Now the reason why I'm getting not a number is because what's happening is this is the window, bark count is undefined, and when you try to add 1 to undefined, you get not a number. Now let's talk about if the browser were to implement set timeout. If the browser were to implement set timeout, you would give it a callback and some amount of time to wait. And you could maybe call some internal method that doesn't actually exist, maybe called wait, something like that, and you would pass it time. And after, it would somehow, lock this execution, and then right after time has passed, you would call back the callback someone passed. But you can see here, dog.bark is passed as callback. And callback is called with just the call operator, right? So, and anytime you call a function with just the call, with call operator, just calling followed by parentheses, no dot, then this is always going to be the window. So this is why, even though you might pass a function dog.bark, you might as it's just like you're doing var bark equals dog.bark and passing that, and then it'll be called as bark. So this is the real important thing whenever you're passing functions to be called back with Ajax, or maybe you're expecting like a click handler with jQuery. Often people will do something like they'll have some element and they'll want on click to call, maybe this is the show button, and they'll have some modal object and they'll want to call show on it. Well, that doesn't work because the context is lost. And we'll see in future exercises how jQuery provides, and now new browsers provide a way to get around this so that show will be called with modal as its, with this as modal. Same way I can make it so that this function is called with this as dog. We'll see how to do that in future trainings. So let's talk about the dot operator, and that's going to, implementing the dot operator is going to be our exercise for this week. So if I had some code like this, I can write foo as an object, point foo to an object, but somehow, even though there's no properties in this object, I can still call foo.toString. And whenever you see curly brace like this is the same as writing out new object. But why can I call this toString? Well, let's see what's going on in memory. So my foo variable points to an object without any properties. Well, it does have one property, but no properties that we created. It doesn't have a toString, but it does have one property that we'll see in a second. Now, this double curly brace is the same as doing new object. So object, there's an object variable in the global call object that points to a function in memory. That function, like I've mentioned before, functions have a prototype property. And that prototype property in the case of object is an object itself but has a toString property that points to a toString method. So on this, when I say that when you use the new operator, you create an instance of an object that inherits the constructor function, which is in this case objects, its prototype properties. I'm going to talk about the mechanism that supports that, which is this magical proto property. So foo points to an object, it has a proto property, and objects constructor function has a prototype property that has a toString method. So what happens with JavaScript is when foo.toString is looked up, it'll look on this foo object here for a toString method. It won't find it. And then it will go up the proto chain to find this object, look for toString there, and then call this toString method. Any questions about that? Have there been any questions, Alexis? You still with me?
Still with you. There have been a few online, so a couple quick ones that I've been answering in the chat room. Some I don't want to go too deep into because.
Alexis?
Couple questions about the video being blurry. Yeah, that's going to be local. For everyone who sees, if you see the video blurry, typically that's latency locally. Every now and then, if Justin's bandwidth goes down, we'll hear the audio go out as well. But it's been so far so good.
So no technical questions. So just pause me if there are any, because it's better to interrupt when there's questions related to what I'm talking about.
Yep, will do.
Awesome. Okay, so let me get back to. Oh, actually, I wanted to show this stuff in the real world, so you can actually see how in your editor this stuff really works. So let me open up my JavaScript console, and this is really good for debugging. Clear all these errors out. If I were to do new, I'll do var foo equals new. Actually, let me blow this up. I'm going to do var foo equals new object. Now, if I look at foo, and I'm going to do it in actually the, if I go to sources, this is a little bit big, it might be hard to see. Let's see if I can make this so it looks nice. I'm going to add my foo as a watch here, so I can look at it and explore it nicely. There's a way to do that without having to go over here, so you can kind of just link into it, but I always forget what it is. Anyways, you can see my foo has a proto property that points to this object.
Console.dir, Justin, will do the same thing.
Is that what it does?
Mm-hmm.
Okay. I never really use that because I'm lazy. Console.dir. Okay, sweet. Let's use that. Okay, so this outputs my foo object, and I can see it has a proto property that has that toString method. But you can also see that if I write if I write object.prototype, that is equal to foo.proto. If I look at the actual object, let me do that console dir check trick again. Console dir this. You can see this function is going to have a prototype property. It also has a proto, but that's the function proto. We can talk about that at some other point. Here you can see the prototype property, and this is that same, has that same toString method. So hopefully you can see how this, is all set up, right? You have your function, your object constructor function that has a prototype object with all those different methods on it, including our toString, and then when we create a foo object that inherits from the object constructor function, it inherits it with simply through this this underscore underscore proto underscore underscore property that points to the constructor function's prototype. And then finally, when foo.toString is actually called, let me get there. When foo.toString is actually called, a call object is created that knows about the function that was called. But this, because we called foo.toString, is the it's doing the .call operator. So this is going to point to the function. That's this pointing, or sorry, this is not going to point to the function. This is going to point to foo, because that's what this is when this function is called. Okay, so now I'm going to go through our exercises, maybe give a few hints on them. The goal is to write a dot function that is going to work just like the normal dot operator in JavaScript. So what I mean is, if I were to write person.name, instead I could call a dot function that I pass it an object and I pass it the property that we want to read. I could also pass it things, and it will not just only walk up on the person on properties. Sorry, let me step back. It will not only find properties directly on the person object, it will walk up the person's proto chain to find properties there as well. So the way to do this, and we'll do it in a JS bin, is to make a dot function that takes the object and the property you want to look up. It's going to walk up the proto chain and keep looking if that object in the proto chain has the desired property. And it'll do that by checking, objects all support this function called hasOwnProperty that lets you know if this object directly has a specified property. So,
hey Justin,
yeah.
We have one question. Could you explain a little bit more about how proto works, or what proto actually is?
Yeah, so proto is just a normal property. It's just like, let me get back to my JS bin with my console here. So, you know, everybody knows I can create a object like this. O is equal to an object, and I can do o.abc equals 1 or something like that. I can create any arbitrary property on an object, right? I'm creating the ABC property. I can create a def property as a string, and I can even assign o dot something else to another object. So I can assign properties to point at other objects. Now, proto is a property just like every other. Think of it that way. Yes, it has underscores. It's special. It's special not in itself. It's special in how the dot operator uses it. So when I'm talking about an operator, by the way, I mean something like this. When you add two numbers, plus is an operator. When you read o.abc, the dot is an operator. Right? When you set ABC, that's kind of a dot and set operator, right? The dot set, it's setting a property on O to some value, right? These are operators. Proto, again, is just like every other property. The only difference is the dot operator, when properties are being read, the dot operator will look directly on, let me go back to that other slide. The dot operator is going to look directly at an object and say, hey, do you have a toString property? And if it doesn't, it's going to walk up, it's going to follow whatever its proto property is pointing to and say, hey, do you have a toString property on that? If not, okay, I'm going to keep going up. So let's look at another quick example. So I could create, I'm going to create I'm going to create, what we'll call this. We'll call this mammal. I've got a mammal object here. And mammals have hair. Now, let's talk about chordates. Chordates are basically animals, but they have a spine. They're animals with a spine. So I'm going to do has spine true. And then finally, let's talk about animals. Animals, let's just say they like eat other things. I don't know what the formal definition of an animal is, but let's just say they eat things. It's true. Now, a mammal, I should be able to do mammal eat things is true. Right now, that's undefined because what's happening is it's looking on this mammal object, not finding and eats things, going to the object constructor functions prototype, which has that toString has own property, not finding anything there, and then essentially just returning undefined. However, let's say I pointed mammal.proto. Let's say I set that equal to chordate. And now, let's say I set chordate proto to equal, I called it animals for some reason when I should call it animal, but let's say I set it to animal. Now, if I do mammal.eat things, I get true. And that's because it's first going to look on the mammal object, which looks like this, but it actually looks like that plus it has hair and a proto property, but it's going to look for it. They say, do you have mammal? Do you have an eat things property? No, you don't. But I'm going to follow mammal's prototype property to chordate. Hey, chordate, do you have a eat things property? No, you don't. Okay, then I'm going to follow chordate's proto to animals. Hey, animals, do you have an eats things property? Yes, you do. You're true. Okay, fine. Then I'm going to return true. So that's what proto does. It's just there for the dot operator. Otherwise, it's just like a normal property. Although in reality, you probably shouldn't set it yourself. There's better ways of setting it and kind of reading and exploring it, because there's a lot of sensitive performance optimizations that get destroyed if you set proto yourself. And I think that it's just becoming like, I mean, it's in, I think IE supports it now. It's just not also supported in all browsers. There's better ways of setting and getting proto, changing proto properties, but for explanation purposes, this is exactly how inheritance works in JavaScript. So that's why we teach it. Okay, so with that, we're gonna try to do this exercise where we actually implement the dot operator, how it's able to walk up the proto properties to find its value. And then once we've done that, we want to write a dot call that you pass in an object, a function to call, and the arguments. So you can actually do something like person.speak by calling person speak and this. So a few hints. Let me kind of show how you would get started with this. Here is the posted exercise that we posted in Gitter and is on Bitovi's blog. Let me size it. You can see here we've created a person and we've added some methods or some values and a method to its prototype, species and speak. And then you can see we have a test where we create an instance of a person and we call dot with person species, and we should be getting back Homo sapien if you implemented your dot operator right. And then we also have another version of that does dot call. So what you want to do is on the right is implement that dot function. Now you'll want to do this recursive. I'm going to give that hint. And I'm going to give one other kind of getting started hint, which is you're going to want to check if object has, let me get rid of the auto run for a second, has own property prop. Oh, not like that, like this. So this will let you know, like in the previous example, if mammal directly has and eats things. If it does, you're going to want to return that by writing object prop. Otherwise, you're going to want to go, and I'm not going to fill out this part, you're going to want to go and essentially call dot with the next item in the proto chain.
Hey, Justin. Quick question from the chat on mammal eats things, mammal.eats things. Does mammal bracket eats things do the same thing?
If you put it in a string, yes, it does. Yes, it does. So one qualifier for this exercise is, yes, you could implement this ridiculously simply by doing object prop. that would work. But don't do that, because that's no fun. You're not walking the proto chain yourself, which is really what we want people to learn and feel like they understand what how the dot operator is really looking for these property values and returning them. We want you to get that sense that it's looking on each object on the proto chain and seeing if it has that value and then returning it. Now, one thing that I actually think we should add, maybe we'll add quickly as a test when we post this exercise, is I don't think there's a null test. It would be good to add. Meaning like, or sorry, a property that's not actually defined. Do you know what I mean, Alexis?
We do have that in the new version, but I don't think I put that in this JS bin.
Okay, yeah, we should add that. So that's one other thing you'll want to check for is there's this special case of there's one object that actually doesn't have a proto property, or its proto property is null, and that's the object prototype object. Let me make this bigger again. If I do object, let me clear it. Object prototype objects, its proto is null. So if you get a proto property that is null, that means you're done. Essentially, like if you try to look at, you're trying to go to the next proto in the chain, but its value is null and it's not an object. Well, that means you've looked through everything in your proto chain. You haven't found a value. You should return undefined. I like to think our exercise, by the way, these exercises are hard, seemingly very hard. That's good, I think. If any of you guys have been playing Bloodborne recently, you hear all the criticism about how it's a really hard game, but it teaches you to actually be really good at the game. I like to think our trainings and exercises are like that. You know, we don't give very simple exercises, but the exercise we give, once you get them, have a lot of meaning and value to them. So once you've got this dot operator, then you can look up property values. The next thing that you're going to need to be able to do is use the dot call, or is to implement dot call. You're going to need to look up the speak value using the dot. So dot call should actually call dot. And then you're going to get a function back. So I'm going to say, like, somehow you get a var function. Somehow. And then with that function, even though we really haven't introduced it yet, you're going to want to call the apply method with what your this should be, what this should be for this function, and I don't know what that is, and then you're just going to want to pass it the arguments. So function apply, apply takes what this should be, followed by an array of arguments it should call the function with. So you're going to have kind of code like this, and then you're going to want to return the result. So that's, I think, good hints. So I think we're done for today. Let me see if there's I think there is a summary slide. So in summary, just let's take a look at a proto chain of a different proto chain. Let's say I created a date object D, and I'm going to assign a foo property to bar on it, right? Almost any object you can just assign arbitrary properties to. JavaScript's nice like that because everything is an object. So I'm going to assign an arbitrary foo property, but then you can see I can call on date has own property method. Let's see why that is. So the date object, when that's created, I'm adding the foo property to it, but the dot operator is going to walk, when it's trying to look up has own property, it's going to walk up from D to find the date prototype object, which is next in the proto chain, which has all the methods like get day, set day, every kind of date related method there, but has own property isn't there. And then finally, it's going to walk up the next stage of the proto chain to the object prototype object and find the has own property method there. So whenever you create a date, you create an object like this whose proto points to the date prototype object, but the date prototype object already has its proto pointing to the object prototype object, which has own property, toString, and those kind of methods. So that's the summary.
Hey, Justin, could you go back to your JS bin? I just want to make sure I get the last hint in the blog version.
Yep. I can just send it to you too.
We're done. Got it. So anybody that's following along in the blogged version, the blog should have just been updated with these hints as well. Apologies, recycling is being apparently destroyed next to me.
What's being? Oh.
There's a lot of bottles being moved next to me. Sorry for the noise.
Cool. So, yep, that's today's lesson. The big thing, actually, the other thing to remember is how this works. This is always determined by how the function is called, not where the function is defined. Following those rules in this slide. Right. Call operator. So whenever you just call a function without a dot before it, this is going to be the window, always, 100% of the time. Whenever you call a function with the dot operator, that function is going to be called with what's the value that's left of the rightmost dot. So in this case, there is only one dot, and the value left of that is puppy. So puppy is going to be what this is inside the bark function. When the new operator is used, this is going to be the instance of an object that inherits from the constructor function's prototype. And when you use call or apply, whatever this first argument is, that's what's going to be this in the function that's being called, in this case, dog.bark. Okay. Cool. So yeah, now Alexis and I are available. If anybody's got any questions related at all to any front-end training topic or things that they want to learn about, we're happy to go over it. Otherwise, we'll just hang out.
We'll also have all the slides, materials from today's session at blog.bitovi.com if you're following along in the lecture series. If you're new, if this is the first time you're watching us, be sure to track back. We've done 3 sessions so far, and we'll also be putting next week's exercises in today's blog post. So you can try some stuff at home, and we'll come back with the answers, our solutions, next Wednesday.
Have you played Bloodborne yet, Alexis?
No.
No. You play video games?
No, I've been on the move. I've been playing a lot of mobile video games because I mean, I don't have a TV. Everything's in storage. For those that are following along, I'm doing a crazy travel the world journey. I'm currently in Calgary, Canada, which is pretty awesome because it's kind of like Texas without the crazy summers. So, which is nice. If anybody is watching from overseas, maybe not live, but if you're watching this YouTube after it's aired, Bitovi will be in India for a series of sessions, maybe a couple meetups. I'll be there long enough I could check out the meetups. And we'll be speaking at the jQuery Bangalore, India conference this summer. So come check us out.
Manu H just asked a question. So Proto can point to any object. Yes, I think it can, except for an object that's going to create a cycle. Let's take a look at that. So this was a fun way to break old versions of Firefox. Is like you could create an object, and then you could do o.proto is equal to O. But it won't let you do that anymore, unfortunately. Well, it actually makes sense. You would crash a browser if you did it. But if you could do this, just think about the repercussions. Essentially, you would keep walking the proto chain forever. Once you try to look up a property that was undefined, you would always just keep looking at yourself forever to find out if you had an object. So o.proto, can you set it to any object? I do think you can. I'm pretty sure, actually, I'm pretty sure you can set it to any object. The only exception that might be weird would be maybe a function. I bet you can do that too. I'm positive you can do that. Function, just one thing I've never tried. Yeah, so you can do it to a function too, and that would now suddenly your O is probably going to have call and apply methods, which I have no idea what this is going to do. Let's see what happens here. Yeah, O is not a function. Even though call is a function, but O is not a function, so it can't really call it. So, yeah, don't. Not probably a good reason to do this, unless somehow I think there is a way that JavaScript is. I've heard something where like you can have functions inherit from inherit properties or something like that. I don't remember what it was, but yeah, you can definitely set proto to any function. It's a good question.
Question from the chat: is proto, or would you consider proto a constructor for the object?
It's not a constructor. I guess it depends on what you're thinking of a constructor. When I think of a constructor, I think of something that like actually builds the object, right? Like in memory, and kind of does all the assignment of like what that object should look like. Kind of build, like if I had an animal, I wanted something to look like an animal. A lot of times I'd create an animal function, and maybe animals have a name. And my constructor function might look like this dot name equals name, and then I might have things on animals prototype, like a say hi method. That's going to just say the animal's name. Now that builds animal, but that doesn't build that defines an animal, but it doesn't build an animal instance, right? In some ways, this is the animal constructor function. It defines the behavior of an animal, but it is not an animal itself. So when you talk about what is a constructor for the object, really the new operator is and the animal function itself. those two things work together to actually create an animal instance. So if I did something like Bob and I did new animal sponge, this new operator working together with a constructor function is actually what creates an animal instance, constructs an animal instance so that I can call Bob, say hi. And I think this is all, is this what we're talking about next lecture, right? Let me check my schedule.
Yeah, this is where we start going into that.
Yeah, so actually next exercise, we actually will build the new operator, the same way we are building the dot operator today. Next section, we're going to build the new operator. So we'll really learn how JavaScript constructs instances of objects. Good question.
Another question from the chat. We've said it a few times. What does it mean when we say this will be the window?
That's a very good question. So in the browser, there is a window object. And this has pretty much everything inside of it. This is the global object that contains essentially all of the DOM APIs, all of the array methods, pretty much everything. This is like the starting namespace. You can think of it as the starting namespace for JavaScript. That and it's like a whole bunch of, it's that and a lot of other things, but you could, starting namespace, starting point for everything. So if I wanted the window document, I can always write window.document and get the document. But I can also, anything on the window, weirdly, I can also just write document. But it's like a starting namespace, starting call object, starting container for everything. It's like the host environment that JavaScript is running in. So when I say I've got a function, here, and I'm going to console log this, and I'm going to run foo. When I run foo and I'm just console log this, this is the window. So that's why I could write, let me get back to my, let's make another foo function. I could write console.log this.document.body, and I call foo. I get the same thing as if I were to write window.document.body. By the way, this is your body element that's in the page. We'll talk about more about these kind of elements when we get to the DOM, but you can see that this, inside this function, is a reference to window. That's a good question.
Another question from the chat.
Mm-hmm.
Excuse me. If you have a parent object and then a child object within the parent,
Mm-hmm.
is that the same as making those two objects separately and then pointing the proto to the parent?
That's a good question. Let me make sure I'm understanding it right. So I have a parent object, and I'm going to have a child object like this. And I'm going to give each one of these things a name so we can kind of see what they are a little bit better. So we have name parent, and this inner one is going to be named child. Okay, so the answer is no. There's not. So it was like, it's not using proto. Let me kind of say what it is. So I have parent here, and I can do child.name. Proto would be more like, I don't know, proto is a different thing where it's essentially saying who parent would inherit from. What this is like is I could do something like this: var child equals a name child. And I'm going to move this up a little bit just because I hate typing so low. There we go. So I can create a child object, and then I can do a parent object. Then I could do parent.child equals child. These 3 lines here, creating a child, creating a parent object, and then setting the parent's child property to point to child, that is the same thing as this code right here. Protos are more used for when like parent is looking up its not name property or its child property. It's used for property lookup. Good question. Any others?
We have caught up to the end of the chat. No questions at the moment.
I'm trying to think like how else to. Yeah, I mean, proto is just another property. It's just used when looking up properties, which is kind of weird, right? But very elegant once you understand it, I think. The big thing to remember is like, yeah, when you say like inside or functions, or like one thing that beginners will get messed up with a lot is not realizing that objects are just objects and functions are just functions, and they'll make some kind of structure which is like, you know, where it's an object and then it's got another object inside of it and then it's got a function. And you know, people will, I think, rightfully call this the structure child my function or something. We'll call it hello. They'll call this the structure child hello function because that is how you would reference it if you were calling it normally, structure child hello. Right, that's a function. It's doing nothing right now, but it is a function that you can call. The big thing to remember with JavaScript is that all of this stuff is very malleable. Like you can add properties, remove properties, call a function in a variety of different ways. It's a very conventionally based language that you tend to structure things in a way that experienced people know, okay, I'm probably going to call it this function in this way. I'm not going to call it with the new operator because it's not capitalized. This is going to work out to be child typically inside here, just because if I'm always calling it this way, that's what this will be. I don't know, we'll talk about these things more in future lectures, and it kind of, I think the conventions just become more visible as you're using the language. But just remember, a function is just something in memory. And this inner object here is just an object that this outer structure's child property points to. There's nothing really magic about any of this. I don't know. That's kind of a weird rant, but hopefully it makes sense to somebody out there. Cool. Well, if that's all the questions we have, thanks for everybody for watching. Next week is going to be a really good one if you want to learn about how the new operator works and kind of close out an understanding of how, if you really understand how the dot operator works, which you hopefully should once we go through the exercise at the beginning of next week, and then you understand how the new operator works, and if you understand how closures work, then really you understand how almost all of JavaScript works. Then we'll start getting to the DOM, and then you'll understand how that works, and then hopefully you'll be able to start building big structures and cool applications. So until next week, I'm Justin Meyer. This is Alexis Abril. Take it easy. Got the thing? No. Yep. All right. Bye.